Greetings, everyone. I'm going to go through the free response question that was given in 2018 on both the AP Calculus AB and BC exams. This is a common practice. They will have some questions that are common to both exams. The BC students will be graded not only on their BC knowledge but on their AB knowledge, and so they need AB questions on the BC exam instead of writing completely separate questions. In total, they'll have some questions from the AB exam on the BC exam as well. So this was number 1 in 2018. Let's take a look. So here's the question, and before I start talking about it specifically, my advice to you is to go ahead and pause the video and attempt this problem on your own. That way you can see how much you know, and then you can come back and watch the video to see exactly how you should be thinking about it in case you weren't thinking about it correctly. That is really the best way to prepare. Just watching me go through and solve the problem without you having tried to solve it first is not going to give you the maximum benefit. And since we're trying to get you to be your best self on the day of the AP, you should go try and solve this without my help. Alright, so go pause the video. Hopefully you're coming back from your own attempt, successful attempt, but if not, that's okay. If you struggled with it, that's normal too. This is part of your studying time. Let's read this together and see what's going on. People enter a line for an escalator at a rate modeled by the function r, which is given by this piecewise defined function. Now, first of all, actually, before I continue, let me say this question has a lot of words, and it's their attempt to put a real-world problem on the test. And I should say world problem in quotes, because who knows how real-world this is. But they're trying to give you a context that would be based on a real-world application of some calculus. And they're trying to make it look a little complicated, so it's a piecewise defined function, and it's got these factors in it. And so they're trying to make it look a little scary to see if they can freak you out. Don't panic. Apply the concepts that I've taught you, and you'll be fine. Now, as I said, people enter a line for an escalator at a rate modeled by this function. So we're given the fact that we're dealing with a rate right here. Little test-taking tip for the AP. If they're giving you a function that's a rate, at some point they're going to ask you to write an integral to calculate a total from that rate, because that's what an integral can do. The integral of a rate will give you some net change in quantity, some total change in that is part of the fundamental theorem of calculus. And so expect that. So make sure you identify the function that they give you. It's a rate. So at some point, we're going to need to write an integral and evaluate it somehow. So r is this piecewise defined function, so it's got this complicated looking piece for t between 0 and 300 inclusive. And note that r of t is 0 when t is greater than 300, which means that the rate at which people enter the line is 0. Okay, so it means there's no change in the number of people in line, or rather entering the line, because this is those entering, not leaving, and that's going to become relevant a little bit later on. R of t is measured in people per second, and t is measured in seconds. It also says in this next sentence here, as people get on the escalator, they exit the line at a constant rate of 0.7 person per second. Here's another rate, okay? So they're giving us two rates. This one's a constant, so you don't necessarily need to write an integral when you get to using this value for something, because writing the integral would be just essentially finding the area of a rectangle, or net signed area of a rectangle if it's below the horizontal axis. But it's not, because it's a positive constant here. Nonetheless, you can use geometry to solve that part. They also tell us that there are 20 people in line at t equals 0. So part A, how many people enter the line for the escalator during the time between 0 and 300 inclusive? So note those 20 people that they talked about over here, those 20 people are already in line. So they don't enter the line during this time interval. They're already in line. So we're not going to count those in part A. That's going to come at a later time. So if we know that the rate of the people entering the line is given by r, and we want to know how many people, that's going to be the integral of the rate function. Like I said earlier, if they give you a rate, at some point you're going to write an integral. So part A just wants you to write an integral and evaluate it. I keep having trouble with my pen here. So this is going to be the integral from 0 to 300 of r of t with respect to t. Now, since we're only looking from 0 to 300, we only need the first part of this piecewise defined function here. I don't need the second part where t is greater than 300, so we're just going to take that first part there. We're going to get our calculator. We're going to get our integral on the calculator, type in that function, make it from 0 to 300, and you're going to get 270 as the value for this one. Pretty easy question. It's worth 2 points. They give you one for the integral and one for the final answer. Let's look at part B. Actually, let me get rid of some of this distracted ink here. So now, this question in B asks us or says, during the time interval between 0 and 300, there are always people in line for the escalator. How many people are in line at t equals 300? So this is going to be, found out using the fundamental theorem. So remember, part of the fundamental theorem or the evaluation theorem says that the integral from a to b of f prime of x dx, some rate function, derivative, is going to be f of b minus f of a. So we want to use the evaluation theorem or the fundamental theorem here to figure this out. B is going to be our 300, a is 0. We want the function at b. We know the function at a, that's 20. We do have to be careful though, because what the question is asking is how many people are in line, and the number of people in line is affected by two quantities. It's not just affected by the rate r, people entering the line. It's also affected by the people leaving the line at this constant rate as well. So we can write this, in one form like this. So we have the initial 20 people in line. We need those people. And then we have an integral, because we're trying to find an accumulation from a rate, the integral from 0 to 300. The rate of change of the people in line is affected by two things. It's affected by r, the rate at which people are entering, and it's affected by the 0.7, the rate at which people are leaving. So entering r, that's like adding, leaving the line 0.7, that's taking away, that's subtracting. And so this is what we're trying to figure out the value of. Okay? So again, there's already 20 people in line. That's where this 20 comes from. That's using the fundamental theorem concept over here. That's the f of a part that I add to the other side. Oops, one more screen. And then I'm integrating the rate of change of the number of people in line. Not just those that enter, not just those that leave. This is the rate of change of the number of people in line. So now you just got to work that out. I'm going to pause and go get the answer. So if you work that out, you should get 80. All right, let's go back to the question. And let me get some of this mess out of the way here. All right, you can do your own active reading by drawing on the picture on the question itself when you work this out. So question C, for t greater than 300, what is the first time that there are no people in line for the escalator? Okay, so we're looking for a time. So sorry, I was going to underline that. First time, and it's for t greater than 300. So, well, we have to add something to the 300 because for the first 300 seconds, there are people entering and leaving the line. So all of that action and the 20 people that were there from the beginning, that all matters, okay? So for C, again, we're looking for a time. So we're going to have 300 plus. All right, so remember what this 80 represented. This 80 represented, let's go back to the question here so don't mess this up. How many people are in line at time t equals 300? That's what we were finding in part B. So I know there's 80 people in line, and after 300 seconds, there's no more people entering the line. Their rate of change is 0. So I only have people leaving the line at 0.7 seconds per person. So now I just got to figure out how do I take that 0.7 and the 80 and get the amount of time people leave? Whoops, let me get to the right screen here. So what we're going to do is we're going to take the 80 people, and divide it by 0.7 people per second, and that's going to give us a number of seconds. To see that, if you need to look at the units, 80 is number of people, so I'm just going to put people. And 0.7 is person per second. A person is a form of people, singular, but per second. So when I divide people by people per second, that becomes people times seconds over people. We're going to multiply by the reciprocal. These cancel. I'm left with seconds. Okay, so this is the answer, whatever that happens to be. You can go work that on your calculator. I'm going to go work it or look it up here, and you're going to get 414.286 seconds, or 285, depending if you round or truncate. This was a 1-point question. There's really no calculus going on here. It's just expressing your mathematical understanding from this. So they don't give you a whole lot of credit, just 1 point. Lastly, part D. I'm going to get rid of some stuff off the screen. Now for part D, it says, for T between 0 and 300 inclusive, at what time T is the number of people in line a minimum? We're looking for a minimum. We're looking on the closed interval. This is the closed interval method. So go look that up if you don't remember, but we're going to go through it right now. It says to the nearest whole number, find the number of people in line at this time. So we need two things. We need the time. It says right here at what time, and then it says the number of people. So we need both the input and the output with a justification for your answer. Justify your answer. All right. So what are we going to do here? So I need to represent the total number of people in line. And so let's do that as a function because I want to take its derivative. So this is based on what we did actually back over here. This gave us the total number of people in line at 300, okay? Because we had the 20 people at the start, and then all the people who entered minus all the people who left, integrated, or those rates integrated, and we got 80 people at that time, okay? So we want something similar to this. So it's going to be those 20 people plus the integral from 0 to some value. I don't want to use t. T was already used, so I'm going to use x. And then we're going to have r of t minus 0.7 with respect to t. All right, that's my function. And I wish I would have called it something from the other side. Let's call that P for people, the number of people at time t. No, it's times x. The time is x in this problem here. All right, so if I want the rate so that I can then take the derivative to set it equal to 0, all that stuff here, this is going to end up being r of x minus 0.7. Because remember, the derivative of 20 is 0, and the derivative of the integral just means we're going to replace t with x and cancel the integral. Derivative of the integral are going to cancel with each other. That's more fundamental theorem, ladies and gentlemen. It's going to be all over the place. You're going to set that equal to 0, so you're going to set your r of x function equal to 0.7 on your calculator. Now, just the first part, between 0 and 300, so that complicated looking expression, you need to figure out when that is equal to 0.7. I'm going to pause and go get that value. And magically, those two numbers are on the screen. So again, graph the first piece of the piecewise defined function, graph 0.7, and then find there are 2 points of intersection. You got to be careful for this one. You might have to adjust your window to see all the possible values. Remember, this goes all the way from 0 to 300, so you adjust your input values, your x values in your window. Your x max needs to get to 300. If it doesn't get to 300, you're going to miss one of these solutions possibly. Maybe even both, okay? So adjust your window. From here, once I have those two values, now I just got to run the closed interval method, so I need to test the function that I just defined. I need p of 0 I need P, whoops, not F, what am I doing? I need P of T1, P of T2, and then P of 300. Now we already figured out, or we were already told rather, that P of 0 is equal to 20. We figured out earlier that P of 300 was equal to 80. So we know those two values. Now we just got to go back over here to this integral expression. And for x, we're going to plug in these two t values, run the integral twice on our calculator, and then get the two numbers that come out of it. So those numbers are approximately 3 I don't know, my decimal point's not showing up. There it is, 803, and approximately 158.070. And so obviously the minimum occurs right here. So you just put a sentence. The minimum occurs at T1, and you just say T1 is that 33.013298, and the number. And note the question said to the nearest whole number of people. Let's see. So it says, notice to the nearest whole number of people. So don't say there's 3.8 people in line. I guess I skipped that D screen there. Whoops. So you'll say at 33.013 seconds, there are 4 people in line. Round that to the nearest whole number in the sentence that you write. Hopefully you're able to get at least some points there. Oh, by the way, part D was worth 4 points. You get the first point for putting, I want to highlight it here a little bit. You get 1 point for doing this part right here, setting that quantity equal to 0. You get a point for getting this root. You get 1 point for these two answers right here, and then 1 point for the justification, for the explanation, just for the sentence. That's the last point. I hope you learned something. I hope you go through this one carefully if you didn't get it, and you study it, because they'll have a similar question this year, I'm pretty certain. Go study.